In Precalculus Lesson 13, we continue graphing rational functions using intercepts and asymptotes and adding additional points where necessary. This lesson is from section 3.2 in the college algebra textbook. The first function we'll be graphing is f of x equals x over x squared plus x minus 2. And I begin by finding the x-intercepts for this function. To find x-intercepts, I would set y equal to 0. The only way that a fraction equals 0 is when the numerator is equal to 0. So I have the x-intercept here of 0, 0. For the y-intercept, well, we would assume it is the same, but to algebraically determine the y-intercept, we set x equal to 0, and I would then have y equals 0 over 0 squared plus 0 minus 2, simplifying to get 0 for the y-intercept, 0, 0. Now, we'll find the vertical asymptotes here. To find vertical asymptotes, I would factor f of x into x over x plus 2 times x minus 1. The vertical asymptotes are determined by setting the two factors of x plus 2 and x minus 1 in the denominator equal to 0. And we get vertical asymptotes of x equals negative 2 and x equals 1. For horizontal asymptotes, we look at the degree of the numerator, which is 1, the degree of the denominator, which is 2. If the degree of the numerator is less than the degree of the denominator, as it is here, the horizontal asymptote is y equals 0. Now we put all this information together and begin by graphing the x-intercept of 0, 0, adding the vertical asymptotes, x equals negative 2 and x equals 1 as dashed lines. The horizontal asymptote, I don't always graph or plot when it happens to be along the x-axis, but I will in this case. Okay, the horizontal asymptote of y equals 0. And then we're going to move on to plotting some additional points. So to plot additional points, we want to know where the graph is above or below the x-axis. Moving from left to right, the only way the graph is going to move from above to below or below to above the x-axis is going to occur at either vertical asymptotes or x-intercepts. So I want to make sure I have plotted some points between x-intercepts and vertical asymptotes. So if we look to the left of this vertical asymptote of x equals negative 2, I can see that I have an x-coordinate of negative 3, and I plug that x value of negative 3 into f of x to find that the corresponding y-coordinate there would be negative 3/4. Between x equals negative 2 and my x-intercept at 0, 0, I find an x-coordinate of negative 1, giving me a corresponding y value of 1/2. Between x equals 0 and the vertical asymptote of x equals 1, I choose x equals 1/2. The corresponding y-coordinate is negative 2/5. Then to the right of x equals 1, I would choose x equals 2, plug x equals 2 into my function, and get a y-coordinate of 1/2 there. So let's go ahead and plot these 4 points. And from these 4 points, we can see to the left of x equals negative 2, the graph is totally below the x-axis. It passes through this point, negative 3, negative 3/4, and approaches both the horizontal asymptote of y equals 0 and the vertical asymptote of x equals negative 2. Between x equals negative 2 and x equals 1, we have the x-intercept there. And note, to the left of that x-intercept, the graph is above the x-axis. To the right of that x-intercept, the graph is below the x-axis. Drawing a graph that passes through these 3 points and approaches the vertical asymptotes looks like so. Then we move to the right of x equals 1 to the point 2, 1/2, which tells us the graph is above the x-axis in that region. And the graph again approaches both the vertical and the horizontal asymptote. This is what our final graph would look like. Moving on to graphing g of x equals x plus 2 over x squared minus 1. I find x-intercepts by setting y equal to 0 here. The fraction x plus 2 over x squared minus 1 equals 0 when the numerator of x plus 2 is equal to 0. Whoops. Okay, and x plus 2 equals 0 when x equals negative 2. The x-intercept then is the point negative 2, 0 on our graph. The y-intercept, we set x equal to 0 and have y equals 0 plus 2 over 0 squared minus 1. Simplifying to get negative 2, we have a y-intercept of 0, negative 2. For vertical asymptotes, we'll factor the denominator into x minus 1 times x plus 1. Then set each of those two factors equal to 0. X minus 1 equals 0 gives us a vertical asymptote of x equals 1. X plus 1 equal to 0 gives us a vertical asymptote, x equals negative 1. Horizontal asymptotes, the degree of the numerator is 1, the degree of the denominator is 2. Since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is again y equals 0. Okay, so graphing this rational function, we start by plotting the intercepts of negative 2, 0 and 0, negative 2, along with the vertical asymptotes, x equals negative 1 and x equals 1. The horizontal asymptote, again being the x-axis, we can put a little dashed line along the x-axis there. Then let's plot some points. So what do we got going on here? I'll show you the points I've chosen, the x values of negative 3, negative 3/2, and 2. Why did I choose those values? Well, the first x-intercept we have here occurs at the point negative 2, 0. And so at the point negative 2, 0, I don't know to the left of that whether my graph is above or below the x-axis. So I choose the x-coordinate of negative 3 there. Between x equals negative 2 and x equals negative 1, the vertical asymptote, we choose, hold on just a sec, okay, so back to between x equals negative 2 and x equals negative 1, I'm choosing the point negative 3/2, not knowing if the graph is above or below the x-axis in that region. And then between the two vertical asymptotes, we get lucky here. Our y-intercept is the point 0, negative 2, which is below the x-axis. And so we know that between x equals negative 1 and x equals 1, the graph cannot cross that x-axis, so has to stay totally below the x-axis. We only need one additional point, and that is to the right of x equals x equals 1. I'll choose an x-coordinate there of 2. I plug each of these x values into my function g of x to come up with corresponding y values. So I'm going to have the points on my graph. Before I put those on, let me erase some of this stuff to clean up the graph a little bit. Okay, so we put the 3 points on the graph of negative 3, negative 1/8, negative 3/2, 2/5, and 2/4. Now I'm going to start sketching the graph to the left of that first vertical asymptote. Notice the intercept negative 2, 0. To the left of negative 2, 0, the graph is below the x-axis. To the right of negative 2, 0, the graph is above the x-axis. So we're going to be approaching the vertical asymptote to the right of the intercept. We're going to be coming up towards that vertical asymptote. To the left of that intercept, we're going to be heading to the left, approaching the approaching the horizontal asymptote of y equals 0, which is the x-axis. So that's what's going on to the left of our first vertical asymptote. Between the two vertical asymptotes, the graph is totally below the x-axis. It is approaching both vertical asymptotes in this region, heading downward. To the right of x equals 1, we pass through the point of 2/4, and the graph again approaches both horizontal and this vertical asymptote of x equals 1. And our final graph will look like this. Now, on your own, number 1, for this lesson, find intercepts and asymptotes and then graph the rational function. Include intercepts and asymptotes on your graph. Use dashed lines to show asymptotes. And the function is r of x equals x plus 4 over 2x squared minus 5x minus 3.